All right, we're recording. All right, lesson 2-5, complex solutions to quadratic equations, our last lesson of the unit. It's a short unit, right? Okay, so today's date is Friday, September 18th, 2020. Our objective for the day, I need to make sure that I can see your guys' cameras. I can't see everyone, and I'm going to kick out Kermit the Frog. Bye.
Mr. Sindel, how come you're in school but not like other teachers?
I have no form of childcare in Mammoth Lakes. I only have childcare here, so I have to come here.
Oh, okay.
Yeah, good question. Our objective, Mr. Gunner, go.
Use the quadratic formula to find complex solutions of quadratic equations.
There it is. Yep. And I was on the fence again. Should I teach you the quadratic formula? Should I make you complete the square? The quadratic formula, as much as I hate it, it does give us the answer really quick, and it works every single time. There's no extra rules that you have to learn. So that's why I went with quadratic formula. It still breaks my heart, but whatever. This formula gives the x-coordinates of the intercepts of the quadratic function with the which axis? It's some axis. Anyone want to take a guess as to which axis I'm talking about? It intersects which axis and where? It gives you the x-coordinates. That should give you a hint, hint, hint. If it's one, it doesn't really make sense. Yeah, Charles?
Is it the x-axis?
The x-axis, yeah. Because if it was the y-axis, it would be 0, right? The x-coordinate of the y-axis is always 0. It's like, that's pointless information. Exactly, yeah. So we're going to assume now that we have a quadratic function of the form ax squared plus bx plus c. Again, a, b, and c are some numbers that might be 1, so they might look like they're not there, but they are numbers, okay? So here is your quadratic formula. Do you guys remember the song? Not if you remember the song. Oh, no one remembers the song from Algebra 1. Okay, I guess I gotta warm up my singing vocal cords here. Let's go ahead and write it down first, and then we'll sing it. Everyone write it down with me. We have negative b. Then it's going to go plus or minus. And it's going to be a giant square root, not too big, of b squared minus 4ac. And that's the numerator. The denominator of all of this stuff, the bottom, is just 2a. All right, are you guys ready to sing? I'll sing it a few times. Oh, yeah, Jade.
Was this from Algebra 1 or did we learn this year?
Algebra 1.
Because I remember this.
Yeah. Yeah, so Wyatt, Jade, and Charles, you have no excuse. You just did this last year. All right, here we go. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. All right, everyone, unmute your microphones.
Yeah, you didn't teach us this, Mr. Sindel.
Oh, okay. We didn't get to that. I guess we just were behind in your class. Sorry. Well, we're learning it now. Sorry for assuming that you have learned this. Everyone, unmute yourselves. We're all going to sing together. We're going to sing it a few times, at least twice. Unmute yourself. Unmute. Unmute. All right. Fernando, unmute. All right. All together. 1, 2, 3. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. All right. I want to hear you guys do it without me singing. On your marks, get set, go.
Negative b.
X is equal to negative b plus or minus
Square root b squared minus 4ac
all over 2a.
all over 2a.
All over the 2a.
God, Zoom is terrible for singing. But hey, we tried. Okay. That's how you remember it with the song. You can also remember it by just completing the square. It will give you this formula. So how do we apply that to example number 1 right now is the question. How do we do the math part of this? So let me do that. Okay, the camera's out of the way. So I write out the formula again. So x is equal to, okay, instead of writing negative b, what is b? What is a? What is c? Well, a here is negative 5. So I'll write a little a above there, including the symbol in front of it, right? And then b is this positive 3, including positive, and c is this negative 2. and I just plug those into my formula, and I'm basically done. The only addition to this from Algebra 1, when we did learn this, we're supposed to learn this, is we might now have a negative under that square root, but you know how to deal with that. That is a complex number now. It's always a complex number, but it now has an imaginary part. So I will do example 1. You guys will do example 2. I think that's a fair division of labor. So negative b, well, b is positive 3. So a negative positive 3 is a negative 3. I'm just copying down the formula here. That is our negative b. Copy down the plus or minus. Copy down the square root. Let me give myself a little bit more room than I need just in case. Okay, I need b squared. Again, b is that positive 3. So positive 3 squared minus 4 times a, which is negative 5. The reason I'm not calling them volunteers is because I feel like it's silly to just...
Wait, isn't B 3x?
That's a great question. So b is only the coefficient. So notice that up here, there's x and there's a b, which means b does not include the x. Yeah, it's an important distinction to make because people always make that mistake every year, and I forgot to say it. So thank you, Charles. Yeah, and then a does not include the x squared. It's just the a, just the number, the coefficient. Yeah, so a is negative 5. And then c over here is negative 2. I filled in the numerator portion of our equation. I haven't done the denominator yet. So let me get that set up. The denominator is going to be 2 all over a, and a is negative 5. And I forgot to say also, Charles, if you could raise your hand next time, I'd appreciate it. I know it's harder with the Zoom interface, and I might go too fast, but you're good. All right, I've plugged in the formula. I need to simplify it, and I'm basically done. If you type this formula into Khan, it might tell you to simplify, it might not. Yeah, question, Jade?
Is that a negative 5 or a negative 6?
I'm called out for my handwriting.
Oh,
I
thought it was a negative 6, and I was like, whoa, I was totally lost.
Yeah, don't you guys know you're supposed to do b times 2 in the bottom already? No, yeah, it's negative 5, sorry. All right, I filled in my formula. It should match up with this. Just plug it into those letters. I need to simplify it. This is where I can get some participation because this is going to require a bit more mathematical knowledge than, oh, a is negative 5. Okay, so I need someone to simplify all of this thing. I'm multiplying negative 4 times negative 5 times negative 2. Who can multiply those 3 things together for Mr. Sindel? Yeah, Jose.
So that'd be negative 40.
Negative 40 is indeed correct. Notice that Jose multiplied a negative times a negative times a negative, which is a negative because a negative times a negative is a positive. Times a negative again is a negative. Someone else, 3 squared. Nice and easy one. 3 squared. Wyatt.
9.
9. So I have 9 minus 40. The numerator, denominator. Random person, Josie. Give me the denominator. Oh, can't hear you.
Sorry, where were we?
Denominator, 2 times negative 5.
Negative 10.
There it is. Josie's given us the denominator. Thank you, Josie. And I can simplify this just a little bit more. Let's do green here. It's going to be now negative 3, sorry, plus or minus. You can do 2 steps, I guess. I'll do this step for us. That's easy. 9 minus 40 is just negative 31. All over negative 10. And notice that 31 is a prime number. So if I was trying to do the factor tree with the square roots of negative 31, I would do this, 31 and negative 1, or the square root of 31 and the square root of negative 1. Notice that the only thing that pops out of there is the I. So there's only one additional step here. And that is, I have, okay, well, sometimes Khan Academy does something different. They split this into 2 fractions. They say that this is a negative 3 over a negative 10, 1 fraction, plus or minus an entirely different fraction, which is, again, square root of negative 31 is just I root 31. Or sometimes root 31i. Just make sure that the I isn't accidentally inside of your square root. Notice how I always have this little tail on my square root to say that my square root has ended. So you could put an I as long as it's clear that it's not inside the square root. All over that same negative 10. Notice that if I do this, then that or the first fraction, -3 over -10, does reduce to +3 over +10, and I have my final answer. Yeah, what?
Could you still keep it in the form with like -3 plus or minus I square root 31 all over -10?
Yes, 100%. I mean, it's mathematically correct. It just depends on what form Khan Academy wants it in. Sometimes it wants you to have it in 2 fractions. Sometimes it's 1 fraction. I'm pretty sure for this assignment, they always change it for different assignments, depending on imaginary and complex numbers. But I'm thinking for this assignment, it's all in 1 giant fraction like this. So now you guys see all the different forms. I guess I'll just box our final resting place, even though multiple of these would be considered correct. There it is. All right. So give me a fist of 5 on how well do you think you could do this problem on your own. I guess Charles, I can't really. Charles is the only one that can shout it out since I can see Gunnar, and then Sergio will shout it out after that. Oh, 3. Well, there it is. 4, 5, 4, 4, 4. Fern, Gunner's at a 3. I can't see. Gunner's at. I'm gonna call it a 3. 3 for Fern and Sergio. What do you got?
4.
4. Okay, cool. Those are some pretty good scores. Yeah, so I want you guys to try to do example number 2. Let's do breakout rooms. I'm going to do groups of 3. Let's see how that works. I haven't tried 3. I've always tried mainly 2. I know sometimes I did 3 if I had an odd number, but I'm going to purposely try for 3 now. So copy down example 2. After you have it copied down, give me a thumbs up so I can like dismiss you guys to the breakout rooms. Thumbs up from Jade. Hand raised from Charles. I'm guessing that's a thumbs up from Charles. Thumbs up from Sergio. Thumbs up from Wyatt. Thumbs up from Gunner. Thumbs up from Josie. Just waiting on Fern and Jose. Jose and Fern are ready to go. All right, let's try this then. Oh, we have 9 people, so everyone's gonna have 3. All right, make sure that everyone in your group gets the same answer. Of course, you're gonna be working privately by yourself for a sec. Check your answers within your group of 3. On your marks, get set, go. Okay, so you have x is equal to -5 plus or minus square root of 5 squared minus 4 times, I need my square root a little bit bigger, 4 times 4ac, so 2 times -1, then in the square root all over 2 times a, which is 2. All right, if you could turn on your cameras really quickly to give me a thumbs up, thumbs down. Did you get that? Did you not get that? Am I ahead of you? Am I behind you? You got it, got it, got it. Okay, cool. So what do you guys think we should do?
Like, don't you solve like the inside first?
The inside of the square root? Yeah.
Yeah.
How?
You do like -4 times 2 and then times that by -1.
Yep, -4 times 2 times -1. What is that?
All right, so -4 times 2 is -8, and then times -1 is +8.
So that's +8, so I can come back over here. What about 5 squared? Let's get Josie to help us out here. Josie, 5 squared, 5 times 5. Are you there, Josie? Sergio, 5 times 5. Oh, she's here, sorry. Josie, what's 5 times 5?
25.
So we have 25, and then this was a +8, so I'm gonna say +8. Okay, this is all over Sergio, denominator.
4.
4, okay, we're getting there. And then from there, we just have to simplify that inside. So this is gonna be -5 plus or minus the square root of, okay, Mr. Sindel will do a little bit of math. 25 plus 8 is 33. 33 all over 4. And look at this one, 33 is not a prime number. It's 11 times 3, but I noticed that 11 and 3 on the factor tree of the square root of 33, they're not perfect squares, and I can't go any further. The square root of 11 is a prime number. Or I guess I should say 11 is a prime number. 3 is a prime number, so I can't go any further, and then I multiply them back together and get square root of 33. Notice that there's no negative, so this one does have an answer that is strictly in the reals, not in the imaginaries. No imaginary.
Wait,
components.
Mr. Sandel, so when there's a negative number, there's gonna be an imaginary?
Yeah, exactly. So your general rule of thumb is if I have like the square root of -5, that turns into I square root of 5. But if I have just square root of 5, that doesn't, nothing happens. The negative basically brings an I out. But just remember,
okay.
we do have harder questions too. Like if I did the square root of -18,
Mhm.
that one is not just I square root of 18. I mean, it is technically equal to it, but that's not reduced all the way. It's not just I square root of 18 because the square root of 18 has a factor tree. You can say the square root of 18 has a factor tree of square root of 9 times the square root of 2. And hey, we know the square root of 9 is 3. This is equal to 3. So really what this should have been is 3I square root of 2.
Oh, okay. So when there's a negative and you put the I in front, you take away the negative?
Yeah, exactly. Because the definition of I is the square root of -1, which is taking away a negative. It's dividing or factoring out that -1.
Okay.
Yeah, great questions, guys.